Hello, welcome you all to today's lecture. Today we discuss operating system concepts that use for evaluating the efficiency and performance of different operating system algorithms, including processing times and disk operations. Now the first thing that we discuss today is the principle of locality in operating system. So it is actually a tendency of programs to access specific data or instruction repeatedly is known as principle of locality. There are two types. One is known as temporal locality, other is the spatial locality. Temporal means that repeat access to the same data over time, for example when we apply loops. Spatial locality means that access to the nearby data locations from current access. We have array traverser, etc. Impact on performance: efficient resource usage, locality reduce memory access time, improve CPU performance, reduces cache misses, enhancing processing speed. In memory management, this principle of locality in virtual memory influence page replacement policies. In disk access optimization, reduce disk input output due to data proximity. Now for process execution metrics, we have different metrics that used. First one is the best time, that time for a process to complete its execution. Then we have a completion time, time when a process finishes its execution. Then we have turnaround time, total time taken from arrival to completion. The formula is that total turnaround time is equal to completion time minus arrival time. Now we have waiting time, time spent waiting in the ready queue. Calculation used for waiting time is turnaround time minus burst time. Then we have average turnaround time, that calculated by mean turnaround time for all processes in a system. Calculation is total turnaround time divided by number of processes. Now then we have a disk performance parameters. First one is the throughput, the rate at which data is transferred to and from the disk, typically measured in megabytes per second or gigabytes per second. Throughput indicates the disk data transfer speed. The second important parameter is the latency, the time it takes for the disk to respond to a data request. It includes the time for the disk to start reading or writing data after the request is made. Low latency signifies faster responses. Now we have a seek time, the time taken by the disk read or write head to move to the required location on the disk to perform read or write operations. Seek time includes both the positioning time and rotational latency. Then we have a transfer rate, the speed at which data is moved between the disk and the computer's memory or cache. It represents the effective data transfer speed during read-write operations. Rotational delay, the time it takes for the beginning of the sector to reach the head is known as rotational delay. Access time, the total time required to access data on the disk, including seek time, rotational latency, along with the actual data transfer time. So that's it for today's. Thank you.